In this lesson, we are going to do animations. Why animation? Because one, render is cool, but obviously you want to animate things. You want to see your cubes, your house, your spaceships move. You want to have control over the camera, and we are going to do these kind of things. But first, we need to learn how to animate in Three.js. Animating in Three.js is like doing stop motion. Actually, most animation in JavaScript works like this. You just move things, take a pictures, move things a little more, take a pictures, move things a little more, take a pictures. The idea is that we are going to take a lot of pictures. We are going to take something like 60 pictures per second, which is a lot. And actually, some computers can run at more than 60 pictures per second. We are talking about FPS. I'm not talking about the game's FPS, I'm talking about frame per second. So this computer I'm looking at right now run at 60 frames per second. But there are computers that can run at a higher frame rate, like gaming computers. And sometimes the computers can run at a lower frame rate, but usually that means that you have performance issues and you have frame rates problem, and maybe you need to change something in your code or in your computer. Anyway, the problem we have here is that we need the animation to look the same regardless of the frame rate. Because if we are moving the same distance, like let's say we are moving a cube, if we move the cube like, I don't know, 10 centimeters between each frame, if there is a high frequency for the frames, the cube will go out quickly, faster. And if we have a low frame rate, the cube will do that slowly, and at the end we will see a different animation. It will not feel the same. So we need to find a solution to have the same result, and we will talk about this in this lesson. So yeah, to do this on each frame, what we are going to create is a function, and we are going to put the object movement in that function, and to call the render in that function. And then we are going to call that function on each frame. And to do that, we are going to use request animation frame. Okay, let's talk about the setup. So I download the usual starter code. I'm taking it. I'm doing it quite fast because now you know how to do this. In the next lesson, I don't think I will be doing this. I open the terminal so you can go to view terminal. And the usual, you just run npm install. It will install all the dependencies we need. Just wait 1 minute, maybe just a few seconds. Okay, it's going fast, cool. And run npm run dev, and it should be opening inside your browser. Great, it's working. So as you can see, we have the same cube as before, and we are going to animate that cube, finally. All right, let's talk about request animation frame. I don't need my terminal anymore, so I can hide it. It's still running. I'm going to need it later, but right now I don't need. So yeah, I can open the script.js file, as always, and we are going to discover what is request animation frame. Maybe you already know, but I have a few things to tell you about this. First, the purpose of request animation frame is to call a function you provided on the next frame. No, request animation frame purpose is not to do animations. Some people might tell you that like request animation frame is for doing animations. They are wrong. The main purpose, the initial purpose, is to call a function on the next frame. Just once you provide a function, this function will be called once on the next frame, and that's all. But the idea is that we are going to create a function, call it, and in this function, we are going to say request animation frame, that same function, meaning that on the next frame, it will be called again. There will be still the request animation frame, meaning that this function will be called again and again and again on each frame. We can use request animation frame to do that, to do animations. But the initial purpose is just to call a function on the next frame. So yeah, let's go. We can do that. I'm going to put my code at the end I'm going to call it animations. Yeah, why not? And you can create a function. So I'm going to use a fat arrow, but obviously you can do function tick, but me, I prefer to use fat arrow. I won't go into details on why I prefer that. That's not the subject. We want to focus on Three.js. So yeah, I created my function and I can call this function right now, like this. And inside that function, so I chose tick as a name. You can choose anything. You can put tag, you can put game loop. I've seen this quite a lot. Loop, anything you want, okay? Me, I prefer to call it tick because it's doing tick, 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 tick on each frame. So it's like a timer, something like that. And inside that function, I'm going to call console log tick. I just want to test this request animation frame thing. Obviously, you have to open the console and go to the console tab. So you know how to do this, I think. And if I refresh, I get my tick, okay? Don't care about the live reloading. It's just Webpack telling you that the live reload is working. Thank you. So we have our tick. What we want is that our function, get called on each frame. And we are going to use the request animation frame. It's very simple. You just write window request animation frame, and the only parameter is going to be the same function, okay? We just pass that function. We don't call that function, we just pass that function. I provide you this function. I'm not calling the function, I'm just providing you this function, and JavaScript will call it on the next frame. And on the next frame, it will say, call it on the next frame. And on the next frame, it will say, call it on the next frame. And you get this. As you can see, I have everything running. I have many ticks in my console, and I actually have something like 60 ticks per second because my computer, my screen, is running at 60 FPS right now. If you have a high-end computer or with a high frame rate screen, you can see more ticks than me. Just watch it. We can launch it at the same time right now, tack, and just watch, you will have more tick than me. So this number will be bigger. Okay, great. So what's next? Don't forget to always call tick at least once at the end, because if you don't call it, I can show you. You have your tick function, but your tick function never starts, and you might, you're stuck. Nothing is happening. So don't forget to call it once. Okay, that's great. Yep. All right, so we have nothing being animated. It's time to do what we said, which is move the object slightly in each tick and do a new render. So let's go. We are going to take the render part, which is this one. Don't touch the set size, just take the render part. I'm going to put it there. Render. Yeah, I'm going to add some comments just for the fragmentation. I don't need my console log. And I'm going to call it update objects. Cool. And here we are going to update our cube. So what we can do, you already know how to transform the cube. We have position, scale, and rotation, and quaternion. But let's keep things simple and use and not use quaternion. So yeah, what I can do is mesh.position.x plus equal and a small value because we want to have time to see it goes. And as you can see, my cube is moving. And now we get the feeling of depth. We have the feeling of perspective. We can feel that we are in a 3D environment, which is very good. Okay, cool. You have your first animation. Congratulations. It's the start of great projects. We have to start somewhere. Anyway, we can do other animation. If you put minus something, goes in the other way. You can combine them. I can put like Y. Allez, come on, positive Y. Yeah, it goes well. And if you want, you can play with the rotation instead of the position. It's going to be the same, 0.01. Sorry, I'm doing mistakes. And you get something like this. Cool. So now you can enjoy the depth, the perspective, which is fine. Okay. Yeah, unfortunately, The higher the frame rate, the faster the rotation. Some of you might have a cube that rotates faster than mine. If you have a high frame rate, the cube will rotate faster because you have more call of the tick function in 1 second. So let's try to fix this. There are many ways of fixing that. What we need to do is adapt to the frame rate. What we are going to use is the time that has been spent. We just need the time value. Like right now, it's you can watch your clock, it's something and 10 seconds. And then after that, it's going to be 11, 12, 13, 14, etc. So we are going to use an information like this. And because it's the same for everyone, regardless of what computer you are using, we can use it to have the same animation. That's the idea. So in JavaScript, how do we get the time? Right now, it's not about Three.js. We are going to use native JavaScript. What we can do is play with time here. And you can create a constant variable. I'm going to call it time because I want to retrieve the time. And what you can do is use a date object and use now, not pow, like this. And I forgot to log it. Like this. Look at this value. It's a huge number, unfortunately. But look at this part. 8, 9, 10, 11, 12. We have something that we can use right now. These are the seconds. But what seconds? Actually, the whole number is milliseconds, and it's what we call a timestamp. The timestamp is how much time has been spent since the 1st January 1970, which is something like a Unix year, creation year, something like this. So it's kind of a reference for computers to get a date, a time stamp at the end. And we can use that. So what we are going to do is compare the current time with the previous time. And we are going to get the difference between those, which is going to be the delta. The difference between the current timestamp and the previous timestamp will be the delta. And we are going to use that delta. So how can we do that? First, we need to get a variable outside. And we need it to be a let, because this variable is going to change. This variable can be equal to date.now, like this. Okay. Then, inside our tick, we are going to get the current time. So I cannot use the time variable, so I'm going to use current time. And get the same thing, like this. And now I have the current time, I have the previous time. I'm going to get the difference between those. I'm going to call it const delta time equal the current time when the tick occurs. And we remove the previous time, like this. But right now we forgot something, which is to update the time once we are done with the calculation of the delta time, because we need to save it for the next tick. So we can just do time equal current time. So I repeat again, I get the current time, I get the delta by subtracting the time to the current time, and I don't forget to update the time for the next tick. If you test the delta time, look at this. Oh, it's not working anymore, too bad. You get something like this. See those numbers? If you are on a good computer with high frame rate, you will have a smaller value, because the delta between this time and the time of the previous tick is shorter, because you're running faster. Okay, great. What we can do now is use that delta time inside our animation. So we can simply multiply this animation by delta time, like this. And we get this result. You can slow it down if you want. Let's say 0.2, 0.002, and you get something like this if it was too fast. Okay, great, 0.001. The idea is that this cube is rotating at the same speed regardless of the frame rate. And that's important. You don't want your website to go too fast. You don't want your website to go too slow. You want it to go at the right speed, obviously. So yeah, that's one of the solutions. Let's see what we can do. Let's see the other solutions. Yeah, we can use the clock. The clock is a built-in solution inside Three.js that will do some kind of the same thing we just did. So let's remove our time. Let's remove this one too, and let's remove this. So we are going first to build that clock. It's a class, so we have to instantiate it. I'm going to do a small comment, and I'm going to use const clock, because that's a clock, equal new, and because it's in Three.js, we can use 3.clock. Very simple. Great. In here, we are just going to test the value, and we can simply call, I'm going to call it elapsed time equal clock, and I can use the function, the method get elapsed time. I'm going to test it, so don't forget to remove the time part here. I'm going to test the value in the logs, which doesn't work anymore, I don't know why, like this, and look at that number. It's a little like the timestamp we used before, but this time it's starting at the moment the clock gets initialized for the first time, initialized. So if I refresh, it always starts at 0. I refresh, it starts at 0. And it's not milliseconds, it's seconds. Okay, so so yeah, let's use this one. What I can do is, I don't know, I'm going to multiply 1 per this. Yeah, just let's use like this. And you will see that my cube, oh, sorry. Yeah, I did a classic mistake. I'm not going to add the elapsed time to the rotation. I'm going to say that the rotation equal the elapsed time. Look at this. Here is my cube rotating. I'm using this time value that start at 0. It's just a second that has passed since the experience started. And I'm updating my rotation with that value. I'm not incrementing it. I'm just taking that value and I put it in the rotation. So yeah, if you want to do, I don't know, like one revolution per second, you will have to multiply it by, can you guess the solution? Maybe pause the video, try to guess the solution. I repeat, let's try to move it like 1 full second per second. It's going to be multiplied by math pi multiplied by 2. Look at this. Yeah, we have 1 revolution per second. Okay, cool. Yeah, obviously you can play with other things. What I can do is play with the mesh position. And look at this. If I use like position dot y and I use the elapsed time, you will see that the cube will just go up. And it will never stop because my elapsed time is just incrementing. And after 10 seconds, my cube is gonna be 10 unit high. Okay. What if I use a math sinus in it? Look at this. So I've used the same value, but inside a sinus. And you can use sinus by using math sinus. We are just experimenting right now. As you can see, my cube is going up and down. Remember the trigonometry exercises from school? When you do something like sin x, you can use actually Google to see that. You get that. So the more x, the more oscillation you get. And you can use also cos, will be kind of the opposite. See, it's starting at 1 and then it drops and goes up again. And when you use sin, no, not psi, it's sin. It's starting at 0, goes up, down, back to 0, up, down, back to 0. What we can do here, just to have some fun, is use a sinus on the y position and use an x on the cos position. and we are going to use the same value on both. And look at this. We have our cube doing circles. Okay, we are just having fun right now. There is no purpose of doing this. I just want to show you that with some simple mathematics, you can get cool animations and you can get almost complex animation, because how can you rotate a cube on a circle? Well, you can just use a value that you increment, which is elapsed time, which get incremented naturally because we get it from the clock, and use math sin and math cos for two different axes, and you get this result, this animation. All right, cool. You can also obviously animate the camera. Yeah, let's do it just for the fun. I'm going to animate the camera position like this. I will get a very similar result, but right now what's happening is that it's my camera moving. Okay, so it seems like it's the same result. It's because the camera is moving just like the cube was moving. What we can do now is tell the camera to look at the cube, which is at the center. The cube is not moving and the camera is moving right now. So we can do camera look at, remember this, camera look at, and you can simply specify the mesh position. And look at this. Yeah, we get something. The camera is doing this, and it's always looking at my cube right here. All right, let's stop with that. You have another method available in Clock. If you watch the documentation, you can see that there is a method called getDelta. Do not use getDelta. You will mess with the internal logic of the class. Maybe it will work, and in another project it won't work. It's because the getDelta is doing stuff with the get elapsed time, and you can get really strange results and values that makes no sense. So just don't use getDelta. You will have troubles, trust me, unless the class is being updated, but for now it's not. Okay, now let's use a library. Why using a library? Well, if you want to have more control over the animation, like creating complex twins, have control on the timing function, the easing. Twins, actually, it's just a transition from A to B. If you want to create timelines composed of twin with delay that can vary depending on other factors, well, you better use a library. It's not mandatory, but sometimes it's better. So there are many libraries around, and one of the most famous one is GSAP. So it's the GreenSock library. We're going to use this one, which is pretty good. So yeah, how do we add GreenSock, so GSAP, to our dependencies? Because yeah, we are not going to use like the index and add a script in here. We're going to add a new dependencies to the node modules right here. To do that, first you have to open the terminal. Obviously, you have your server running. So two solutions. You can create a new terminal by clicking here, or you can open your terminal, your computer terminal, your OS terminal. Or what you can do is close the server by pressing Ctrl+C. And right now the server is not working anymore. So if I try to update the page, obviously I have nothing. And then you will write npm install, you know this one, but we are going to add GSAP. Don't press enter yet. If you did, don't worry, you can just write the next command. So doing this will add GSAP to the node modules, but what we need is to specify a version. And to do that, I'm going to add at 3.5.1. Why do you need to specify a version? If you don't do that, it's going to be the latest version, which is fine for most of the projects. I need you to do that to make sure that we have the same version. While I'm recording, it's the 3.5.1. And if you fetch a new version like 4 or something like this, you might have errors because it's not going the same code. All right, so for your personal project, just run GSAP. But for this lesson, you have to add 3.5.1 so we get the same version. And then do not press enter. You have to add dash dash save. Be careful, there are spaces around it. So why do we add dash dash save? Adding dash 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 save will add the dependencies to the dependency to the package JSON file. Why do we need to do that? Well, it's because if another developer wants to work on that project, he will fetch the project, run npm install, and it will install the GreenSock library because the GreenSock library will be inside that package.json file. That's all. This is how we use dependencies and save those dependencies. So yeah, you can run it. So npm install dash dash save gsap at 351. Just press enter, wait a few seconds, maybe a few minutes, depending on your bandwidth, and you should have access to it. Don't forget to relaunch the server, npm run dev. My server is running. I can actually close this one and use the one already open. Yeah, that's the one. I can close the terminal. Nothing changed, but now I have access to the GreenSock library from my script. To do that, I will simply write import gsap from gsap, like this. And if I log it, just to see if there is something inside, yes, I have something, which is perfect. This is a GreenSock library. So as you can see, it's not exactly the same way of importing, and you can actually import very specific part of GreenSock, but this is not a lesson about GreenSock. We are going to use it the most simplest way. So yeah, let's use GreenSock. So this is the variable you're going to use to create animation like timelines, twins, stuff like that. And to start with, very simple, we are going to do a small animation by doing gsap. We are going to call the to method. And in the to method, you have to provide two arguments. You can do more, but we are going to provide just two arguments. First is what object we are animating. In our case, it's our mesh, but not just our mesh. It's going to be our mesh position. We are going to do something like just a small animation, like it's going to go to the right. So for you, it's that direction. So we are not animating the mesh, we are animating the mesh position, okay? It's going to be mesh.position. And then you have to send an object, and in that object, you have to specify the destination of the different properties. We are going to simply animate the X property, so I will specify X2, like this. And obviously, you also have to provide a duration for the animation. It's going to be duration, I'm going to use 1. And you can also provide a delay, meaning it will wait X seconds before starting. So I'm going to add a delay of 1, 2. So we can have time to see the cube starting the animation. Okay, I think you can save. Look at this. 1. And it's moving. Great. And if you want to do, you can put it back. If I add a delay of 2 and x0, look at this. Doom, doom. And it's coming back. Great. We are not going to go further. Even if I really want to show you more about animation with GreenSock, we have to keep things simple because we are going to do a better animation in the next lessons. Just keep one thing in mind, is that GreenSock has its own tick, meaning that internally the library is doing request animation frame on its own. So you don't have to tell GreenSock to update itself, but you still need to render the results by yourself. So all we have in our tick is renderer, render. Nice. So we've seen many solutions. Which one should we choose? Well, there is no right answer. It really depends on the project, on you, on the libraries you know, on the features, on performances, on the weight, because when you load libraries, it's your project project get heavier. So you have to really decide, analyze, and choose the right solution. Many times you just need to do like a cosinus or a sinus and you will get the perfect result. But sometimes, like if you want to do, I don't know, like a sword doing like a very strange movement like this, you better use twin animation libraries like Greensock. So it really depends on the project. Okay, cool. So we are done for this lesson. And in the next lesson, we are going to play with the camera and have more control over it.